Okay, should I just, is it Berkeley time? Okay, yeah, it's Berkeley time. Okay, it's Berkeley time, so I'll get started. Surprise guest lecture today, because I'm presenting these slides. So, yeah, today we're going to be talking about Kubernetes. So, title of this presentation is What is a Kubernetes? And I give this presentation very frequently. Um, so before we talk about like what Kubernetes is, let's talk about why Kubernetes is, right? Like everything that you do needs to solve some problem. We don't just do things for no reason. The reason that we have Kubernetes um, is probably best explained through an analogy. So in computer science, like you might identify like one fundamental problem is like how do we write software, right? It's like programming languages. I want to like write some software that achieves some goal. So that's like a fundamental problem in computer science, right? So I think the fundamental problem in computer infrastructure is that like given we have some software that people have written, how do I best run that software? And what does it mean to run software? It means you need to assign applications, which is like software that people have written, to resources. And resources can be anything. Resources can be like CPU, RAM, disk, or they can be like money. They can be time, like how much effort does it take me to deploy this application? Um, you can exchange money for these resources up here. So like the specific subproblem that you might be interested in just in solving is like, what is the best way to organize or spend our resources in order to run some software that's already been written? And best has an asterisk because uh, best can mean a lot of different things to a lot of different people. And even more specifically, what Kubernetes solves is given we have a bunch of computers that are already running, that already exist, how do we best like organize these computers that already exist to run our software? And yeah, best is asterisk because best means many different things, like efficiently, but like what does efficiently mean? Like at scale, like what does that mean? Something more concrete is like minimal downtime. I want my app to always be available. Um, Something that's often overlooked, I think, when people are learning about this stuff is like you want people who are good at things in any given organization. You want people who are good at things to be doing those things, and like everyone should just like do the thing that they're good at, right? And maybe you like all of you hopefully are the people who are good at running computer infrastructure. So that should be your job, and the job of people who write software is the job of people who write software, and they're good at that. And Kubernetes helps you like split these two worlds apart, where people who are good at running infrastructure can just run their infrastructure and give the people who are writing software like a nice clean interface where they don't have to worry about a lot of the problems that we usually worry about. So yeah. So okay, with all that out of the way, any questions with about my philosophy? I don't expect there to be any, but yeah. So with that out of the way, what is Kubernetes? So Kubernetes is a database. Everything is a database. So in particular, well, a database is one part of Kubernetes. I break it up into three parts for purposes of this. The first part is the database. The database has three interesting features. So the first thing is that it's distributed, which means that if you have multiple computers that are running Kubernetes, they all have like the same copy of the database. And like if I write to one copy, it'll like exist in all the other copies. If I read, it'll be the same. You have some guarantees surrounding that. You had a question? Okay, no. Okay. The second thing is that it's key value. So it's like a hash map. I put in some key and I get a value back out. That's how the database is structured. It's not SQL or anything like that. It's just key value. And the last thing is it's typed. So I can have like, I don't know, your typical like Java examples, you can have like an animal, or you can have like a person or a user, and the user has like certain fields like a name and an age or whatever, and the animal has like number of legs. So there's types and there's like a specific schema for those types. Okay, any questions about the database inside Kubernetes? Okay. I think it'll like come together later, hopefully. Or if not, I will talk a lot more. But yeah, so some examples of objects that exist in the Kubernetes database are like, now that I'm looking at this, I think this is like needlessly abstract, but like make X software available at web address hello.example.com is an object, right? And I say right, it's not obvious at all. Like what that object looks like is something like Like this container, like it might be an object with two fields, like a name and then like the address hello.example.com. And the object does not have any information about like how to actually achieve this. The object just says like there should exist this software at this address. Does that make sense? Okay, cool. Okay, we'll skip this for now. So yeah, here's like a very, very concrete example of something in the database. So as we can see, this object has a type. The type of this object is called deployment. There is a key, which is its name, nginx dash deployment. And and it has some data, which is in here in the spec. And we can make this anything we want. Yeah, okay. So far that was just the database. We were just storing data, like nothing has actually been done. We just said, let there exist this software, right? The second thing actually looks at the database and then like figures out how to make that a reality. So that's the controller software. So it looks at the database and then it says, okay, there should exist software that at this address, and then it like configures nginx, for example, to point that address at that website. Or it can do anything else. It's just code, it's software. Okay. And then like the third thing is like it's standardized APIs for all the above, right? You can build your own database and your own controller software that looks at a database, but it doesn't follow the same standards, so it's like harder to integrate. But Kubernetes is just like standardized. Every type has a version. So if like the platform owner updates deployment to like version 2, all of your like version 1 deployments don't suddenly break. And also importantly, it's universal. What happened here? Oh yeah. Also importantly, it's universal, which means that like every cloud supports Kubernetes pretty much, or you can deploy your own Kubernetes. Whoever you get compute from, you'll be able to use these APIs. So yeah, here's the version in the object example. So the version of this one is v1 beta 1. Yeah, okay. So any questions about controller software? I'm talking kind of fast, I realize, but feel free to ask. Okay. So other details that I think are like less important. So now we're like firmly out of the realm of philosophy. Kubernetes is a container orchestration system, but I haven't even talked to you about containers yet. So containers are like why we're able to use this for deploying infrastructure. Like why we can do this now and not 30 years ago. Because if I have a container, if you remember from like the Docker lab, you just like give a pointer to a container and you can like pretty much fungibly run that container on any hardware and it'll do the same thing. So that allows you to write the controller software much easier because you can just, if the object says this software needs to run and it should use this container image, like I don't have to think too hard about like where that runs. I just pick any machine and I can run it there. So we talked about this a little bit in Docker lecture, but just to reiterate, container is a packaged app. In more detail, it's a standard. OCI is the name of the standard, sandbox process. This is the standard. And it's implemented as a set of isolated processes that are separated by namespace. Different namespaces are like network namespaces, C groups, file system. So for example, C group namespace means that if I were to type PS, pop quiz, what does PS do? Anyone know off the top of their head? Keon. I mean, yeah, I list the running processes, right? So if I am in a different C group namespace from another process, I can't see the same. Wait, this is true, right? I can't see the same processes. This is process namespace. I messed up. Okay, yeah, there's another namespace that separates processes. If I ran PS in one process namespace, then I would not see the same processes as a different process namespace. C groups are for resource limits, yeah. And then, yeah, file system makes sense. It's just like if I visit a file, it might be a different file depending on which file system namespace I'm in. Okay, so yeah, why is this better? So we talked about like why Kubernetes is, like why is it better than like any given alternative? So Kubernetes works on multiple machines. So I can have many different computers in that server room over there, and they all run like one Kubernetes cluster, and I deploy software to it and it goes on somewhere. And unless I specify where, it'll just pick wherever it thinks it's best. The second thing is like a bit of a more nuanced point, and that is like it enables this thing called declarative infrastructure, which means that instead of writing like, oh, SSH into the server and download the software and then run it, I just say the software should exist, and there's control software that someone else wrote or maybe I wrote that will make that happen. And this is really powerful because if I want to change how my software runs, I just say, now there exists this new software, and the control software needs to figure out, oh, I need to delete the old software and reinstall the new one. I don't have to think about how I like migrate my current infrastructure to the new infrastructure. So yeah, you can think about this as like SQL to C versus like Kubernetes CROS. In SQL, you say select where foo equals bar and like whatever other clauses, and it just like finds you the thing. And C, you'd have to write like for item in items if item dot name equals whatever, and you can do all sorts of other stuff. So I'm not saying one is like strictly more powerful than the other, but I mean, hopefully that gives you a flavor of why it's different. Okay. And the last thing we're going to do is like an example of a specific thing that Kubernetes lets you do, which is like probably the most important thing for like actually using it. But I put it at the end because I actually think it's an afterthought. And if you're using Kubernetes, like the philosophical stuff is like way more important. Otherwise, you're just going to be mad at your computer. Okay. Any questions about any of the previous stuff? Otherwise, we will jump into an example. Okay. Unsure if no questions means everyone is lost or if everyone is totally getting it, but I feel like that usually means lost. But that's okay. Okay. Specific example might help. What if I minimize this? Okay. So here is an object inside Kubernetes. As we looked at before, the object has a version, it has a type, it has a name, it's the key, and it has some data. So this object is called a pod. And what a pod is it's an ephemeral existence of a container. So a pod object existing in the database means the controller software needs to run a container on some computer somewhere in order to like fulfill its end of the contract. It needs to make this container run. So in order to do that, what information would be useful? Like maybe like the image name, and then like what ports to expose. Right. So this you just tell it like I want this container to run somewhere, it'll run. This isn't super interesting, right? Like you can just Docker run. It's like basically the same thing. But this is like probably your like fundamental building block of like why we can use this for infrastructure. Okay, so then there's another object which is called deployment, and deployment will create a bunch of pods. So I said it represents a set of fungible containers. Fungible is like kind of important. Yeah. So we can see that we have this object called deployment, which says that the controller software should create pod objects. So like this is like a little indirect. The object tells the controller software that the controller software should make more objects. And when the controller software makes those objects, which are pods, then the controller software will see, oh, there are pod objects, therefore I should make containers. So it's like it bounces back and forth a little bit. That's what this is. So as you can see, inside the deployment object, there is the metadata for not the metadata, the contents of the pod object, because the deployment object needs to make the pod object. So it needs to know what the pod object should look like. So also sort of interestingly here, you need to give the deployment a label, and it will apply that label to, or you need to give the deployment a label, and it uses this label in order to figure out which pods belong to it. So when I delete the deployment, it should also, actually this is not what how deleting it works. For various reasons, it needs to know that which pods belong to it. Yeah, so confusion. How did I make this work? Okay, so other things you can do are like this is a service object, and the service object contains a pointer to an ingress. Wait, that doesn't make any sense. What? Okay, I don't know what this slide is supposed to do. This is network flow slide. Oh, okay. This makes more sense. Okay, so This shows you a couple of objects. It shows you an ingress object, a service object, and a pod object. The pod object probably has like a port exposed, and you can make a service object that says there is a port exposed on some pod somewhere. And you can make an ingress object that points to a service object that says this service should be accessible on this website. So if I had an ingress object that said argo.ocf.berkeley.edu, and I created these three objects, I would be able to visit argo.ocf.berkeley.edu from my web browser, and I would connect to this pod. Yeah.
So like the object is like some list of predetermined objects that like the VM does not have handle, or like you define your own objects from that?
Yeah, great question. So Kubernetes is made up of a bunch of components. There is a built-in control. There are many pieces of built-in controller software that define like built-in objects, basically. And some of those built-in, like every Kubernetes cluster, I'm pretty sure will have a pod object because the kubelet controller software knows how to handle that. But you can also write your own software, and it's like very common to do this. It's called the operator pattern, or what happened? Click. Anyway, yeah, it's called the operator pattern, but you write your own software that looks at the database and then does whatever it wants. So I think on the next slide I actually had why is it doing that? Why did it turn inverted? Oh, that's kind of interesting. Anyway, so for example, I wrote a piece of controller software kind of for fun called Mycelium. And what it does is it lets you create an object called Minecraft set. And you give it some like high level information about the Minecraft server, like it should be a paper Minecraft server on version 1.18.1 and like uses these Java arguments. And in response, it will create one or many Minecraft servers. And there's also another object called a Minecraft proxy object that will like create, if you're familiar with Minecraft, this will make sense. If not, it won't, but don't worry. It'll create like a proxy that connects to all the different Minecraft servers. So you can create a bunch of mini game servers and then make a proxy that points to all of them. But yeah, you can imagine doing like anything with this. And so there are funny ones where people like order pizza with Kubernetes, but there are also useful ones where like if I want to run a Postgres instance, Postgres is like pretty hard to run software. You need to think about like backups and like you might want to install plugins. So like doing it directly by making a container is a little annoying, and it's sometimes much easier to just make a thing called Postgres and it just like makes the Postgres for you. So yeah, there are varying levels of usefulness with these controllers. And like endless amounts of hacks. Yeah, you can look at mine. This is advertising. That penguin is very scary, but yeah, that's it for dark mode penguin. Yeah, Keon's dark mode browser. Okay, yeah, that's it.
I can like work on them later, but I think I don't know if I missed it or not, but I thought like from the example you showed, this thing looks very similar to Puppet, like we learned last week. So what are some of the differences between the two, or it just like completely, you know?
Sure, yeah, it should look similar to Puppet, right? So it is trying to solve the same problem. Like the reasons that I tried to give of why it's like different from Puppet is that like okay, I guess this sounds like Puppet also works on multiple machines. But it treats machines as more fungible. Like in Puppet, I guess in Puppet you can have like a Puppet class, then it applies to all the machines. But in Kubernetes, part of the deal is like I don't really care what machine it runs on. I'm kind of lying because there are ways you can make Kubernetes care. Okay, this is getting really confusing. In Kubernetes, you typically do not care about which machine your software runs on. In Puppet, you do. And then like the whole thing about declarative versus imperative, Puppet is definitely more of like you write code that makes it do this thing first and this thing second. Yeah.
Thank you.
Yeah, what's up?
No.
What?
Well, I mean, Puppet and Kubernetes are sort of like, they solve similar problems and have
Yeah.
like, there's some like similar things about them. Like they're both sort of declarative. But I think like Puppet, they're like at like different levels of like abstraction.
Yeah.
Like Puppet, it's like you have an existing OS. It's mostly for like it largely works the same way that like computer infrastructure has worked in like the past like couple decades. And it just like configures your like already existing OS. Kubernetes is like this whole new thing that's like, it's sort of like an entirely new way of thinking about running software, right? So it's like they solve the same problem in their like respective domains.
Yeah.
If that makes sense.
Yeah. So yeah, you bring up a good point, which is like, if I have a bunch of computers that run Debian Linux or like even Windows, I have a friend, Ethan HS, who uses Puppet to manage his Windows desktop. But like, if you have a computer that already exists, like Puppet kind of just like is like a hack almost that is just like bolted on top where to like connect and configure things. And Kubernetes is like, what if we redesign this from the ground up and instead of like SSH and running programs, we just like made objects and controller software and all this different stuff.
So does it all live on the server, on like the local? I guess both, right? When you say creates objects and stuff, those objects.
Yeah, so the objects live inside the Kubernetes database, which is like distributed across all the computers that run Kubernetes. That is a simplification a little bit, but we won't get into it too much. Okay, cool. I will let you do it.
Yeah, thank you.